Start out, soil sampling checks the soil's ability to supply nutrients for plant growth, which is essential for site preparation. Once those plants are in the ground, it becomes very difficult to get some soil nutrients into the soil. Things like phosphorus and potassium move very slowly unless they're incorporated, and it becomes very difficult. So also it avoids under or over applying any fertilizer or wasting money doing so. You know what's in the soil and you know what needs to be added. Tools for sampling include soil probe. It's available at some county extension offices. Alternatives might be an auger, which is often used in rocky soils, or barring that, a spade and a knife to take a sliver of soil for sampling. Have clean buckets, not galvanized, because that can introduce zinc contamination. And then also include sample bags and submission forms. Sometimes a soil testing laboratory will provide those sample bags for you, or a brown paper bag also works. Samples can be collected during most of the year, spring through fall, anytime the soil is not frozen, saturated, or very dry, which can make sampling difficult and affect the results that you get back. If comparing results over time, it's best to be consistent. So for instance, sampling in the spring or the fall, because this can affect the results that are generated by the lab. Though if only can take a sample during a certain time, it's better to take that sample rather than not take it, because the effect of season is rather minor. Pre-plant, minimum 6 to 12 months, especially for blueberries. The 12 months is important because it takes time for sulfur, which we use to reduce the pH, to react. It's a biological process whereby sulfur is taken up by bacteria and microbes, and they spit out sulfuric acid, which does the acidifying. It takes up to 12 months to do that. Then sample before you add any nutrients, and then 6 months after applying any of them to check how those nutrients have affected the soil, and then maybe that'll tell you need to add more. Establish plantings every 2 or 3 years, or as needed for troubleshooting as problems arise. And then I recommend for blueberries annually up to the third year, to monitor the pH, because the pH will change over time. That'll head off any problems with high pH in blueberries. The sample area should be based on soil qualities. So any radical changes in soil, changes in slope, which can indicate erosion, texture, and drainage classes should be sampled separately. Great way to do this is to log on to Web Soil Survey and then play around with the Soil Data Explorer. At the UKREC, our horticulture testing area, have Sadler and Zanesville, and they're very similar, which means we don't have to change any or take separate samples from those two soil types. We want to avoid fence rows, manure, or burn piles, because those will be radically different from the surrounding soil. Exclude those. And then separate by management areas. That includes separate peach blocks from apple blocks or small fruit blocks. And then any areas where different fertilizer uses have been applied. Separate young and old blocks as well, because they have different nutrient requirements. And then if we have problem areas, take a separate sample from the poor growth area and the good growth area as a comparison. Collect from all sections of this desired sample area for pre-plant. Cover the entire field or the entire area they want to plant, and subsample in a zigzag or random pattern across that field. You can do the same thing in established plantings, but it should be a plant in the planting bed or the drip line where most of the roots are, not in the aisle. For soil sampling, the more cores that are taken, the better for accuracy. 8 to 10 cores for areas less than 2 acres, and 10 to 20 at least for any area larger than 2 acres for horticultural crops. Depth, small fruit, it's appropriate to take a sample from 0 to 8 inches. This covers a majority of the root zone, especially for strawberries and blueberries. Blackberries and raspberries have a deeper root system unless they are on a restricted soil layer. In this case, if not unrestricted soil, you can sample at a deeper depth because there are going to be some roots down there. Tree fruit, they have deeper roots. So sampling at a 0 to 8 inch profile and an 8 to 16 inch profile. And then this is used to compare and contrast results because they can take up nutrients from the deeper soil profile. For instance, if the upper soil profile is medium and the lower soil profile is low for certain nutrients, we can add more of those nutrients based on and to make up for low amounts in that deeper soil profile. So it can increase or reduce the rate just depending on that, but we will need 2 labeled clean sample buckets to avoid confusion. Collect those samples in a bucket as you're taking the cores. Remove any large organic matter pieces and any large stones. Then air dry if it's wet and sticky. Many of our clay soils get sticky when they get wet. And do not oven dry because this can affect the results, especially for organic matter. Then once it's dry, mix and break up the large clods. You don't have to break them up into very small sections or pieces, but it should be fairly well mixed. And then add any necessary information to the sample sheet according to what's directed by the sample lab. Include a desired analysis, any extra tests for nutrients you want done, and then choose descriptive sample IDs, ones you can remember, and then keep a record of that so you don't forget between the time you collected the sample and by the time the sample results are returned. Label and fill the sample bag to the line or add about 2 cups of soil and that'll be more than enough. Analysis options. The common extraction methods used in the Midwest and Upper South include Melick-3. That's the one that the UK Soils Lab uses, and this will cover soils with a broad pH range. It's appropriate for those. Gray P1 is for pHs, any soils that are below 7.4, and then Melick-1 are only for acid soils. I would just choose Melick-3 because that's the most common and one that have experience with. CEC, some of the results returned will be CEC, which is cation exchange capacity. And that's 10 to 15 is normal for loams. Cation exchange capacity is the ability of that soil to hold cations or hold certain positively charged soil nutrients, especially potassium, calcium, magnesium are the major cations. pH, water pH will be the actual acidity of the soil. And the buffer pH will be the resistance to change, how difficult it is to change that soil pH, which is important for liming to raise the soil pH and sulfur to reduce it. And then some soil tests will return organic matter. 2 to 3% is normal for unamended soils in Kentucky. Nutrients returned will be phosphorus, potassium, calcium, magnesium, and sulfur on many soil tests. So sometimes you have to request sulfur to be added. Nitrogen will not be included on many soil tests, including UK test from the laboratory, because it's based on, and any results you get back will be based on annual crop requirement. It's difficult to test nitrogen in the soil and get a meaningful result because it is so variable. It changes over time, and soil conditions can change the availability of nitrogen to plants. Micronutrients include boron, zinc, manganese, iron, and copper. But from soil testing, they are not very meaningful because they do change over time. And what's in the soil may not be available to the plant. So foliar testing is a better indicator of status. Sometimes you get to choose which ones you can, of the micronutrients you can test for. The two top ones for me would be sulfur, boron, and if I could add a third one, it'd be zinc. pH has a very substantial impact on nutrient availability. For most fruit crops, a pH of near neutral, 6 to 7 is recommended during production. And this is because all those nutrients, macronutrients and micronutrients, are available or most available between a pH of 6.4 and 6.8. Blueberries are the odd one out. They require a pH for good growth and productivity between 4.5 and 5.2. As the pH increases, micronutrient availability to plants decreases, especially for iron, and blueberries are heavy users of iron. While for the macronutrients, as the soil pH decreases, their availability to the plant decreases as well. But for blueberries, they're not heavy users of those macronutrients. The common fertilizers available to growers in Kentucky include urea, ammonium sulfate, calcium nitrate for nitrogen, diammonium phosphate, which contains both nitrogen and phosphate, triple superphosphate for phosphate, and then monopotassium phosphate, which contains both phosphate and potash, as well as potassium sulfate, which contains sulfur as well. So let's do an example of an interpretation based on a real soil test. The crop to be grown pre-plant, this was taken, is blackberries. And based on UK standards, phosphorus in the soil is squarely in the medium range, the middle of the medium range, which is 35 to 70 pounds of phosphorus per acre. Potassium is also squarely in the middle of the medium range, whereas magnesium and calcium are high and very high. Ignore the bars. They don't tell you very much on this soil test. Soil pH is near neutral, and the buffer pH is very high. Sulfur is from the lab is shown to be low, but UK has not established standards for soil sulfur or for soil boron. So take those with a grain of salt. From the fertility recommendations, nitrogen is recommended at 40 pounds, but remember this is based on the annual crop use requirement. But if it's applied pre-plant, can be used for establishing the crop, establishing a cover crop, or establishing a sod aisle before planting. Phosphate, recommended to add 40 pounds of phosphate per acre, which seems reasonable given that it's right in the middle, 0 to 80 based on UK recommendations. And for potash, I've recommended 60 pounds. These are maintenance recommendations because at the medium range, we might or might not see a crop response from adding more soil nutrients or nutrients to that soil. It seems a little bit high to me, the potash, but plants tend to use more potash than they do phosphate. And then it recommended 17 pounds of sulfur from that. using diammonium phosphate for the potash, 40 pounds in recommendation, 100 pounds from the recommendation, in 100 pounds of that diammonium phosphate, there will be 18 pounds of N and 46 pounds of phosphate. That's 46 represents the percentage. Divide that 40 by 46, or 0.46, which is the percentage expressed as a decimal, and that gets a recommendation of 87 pounds of DAP per acre. This will also add 16 pounds of N. We can make up the difference with 24 pounds of urea, which means that to make up the difference, we'll spread 52 pounds. For potassium sulfate, dividing 60 by 0.5 will give 120 pounds of potassium sulfate to meet that 60-pound recommendation. And this will also add 22 pounds of S. So part of the interpretation is based on grower needs and desires. And if we're buying DAP, urea, and potassium sulfate in 50-pound bags, because we're in the middle range, it's okay to round up to 100 for a DAP. That way we don't have 13 pounds left over. And round down to 52 pounds of urea, or 50 pounds of urea. It's not going to make much of a difference. And if we don't want to buy a third bag of potassium sulfate, it's okay to round down to 100 and spread that 100 pounds. Because we're in the middle range and it's pre-planted. It's better though to go with the higher rates, because the amount of phosphate and potash recommended is for the entire life of the planting, and it can be a form of insurance. Now, I sometimes get questions about from growers that want diversified plantings and say, well, I like want to grow blackberries, but I also want to grow blueberries on the same site. Well, blueberries are the odd one out. The CEC of this soil is typical for loams, but the soil pH is high and it has a high buffer capacity, which means it's going to have a high resistance to pH change. The calcium levels are also above 2,500 pounds per acre, which means that there's a lot of carbonate in there, and it's going to be difficult to maintain that pH over time. If we wanted to go ahead, going from 7 to 4.5, we'd have to add 2,560 pounds of sulfur to lower that pH to 4.5. This is a cost prohibitive in my opinion, and it's likely not to maintain that low pH. So for this site, blueberries are not recommended. Better to find another site. So to accurately interpret, we need to know that test ratings on that soil sheet or that results are relative. The laboratory can end up having as many or as few ratings or ranges as they want. UK uses low, medium, and high. The low range, we add nutrients to the soil, we're likely going to get a yield increase. At the medium range, adding nutrients, we may get a yield increase, especially for the low end of medium. But at the high end of medium, we're unlikely to see a result. And then at the high range, no nutrients are recommended according to UK, because we're not going to see a crop response, and we'll just be wasting money and wasting fertilizer. So understand that there's different recommendation philosophies as well. The one that UK uses is a crop sufficiency. It's based on the expected crop response, and no fertilizer is going to be added if the rating's high. Again, sometimes some soil labs use a maintenance fertility philosophy, and that means that over time they're going to recommend that the nutrients be built up to the medium or high rating, and then they're going to add extra to replace harvest losses. But these are estimates based on high yield, and high yields are not always high, and sometimes they overestimate the amount of nutrients that that crop is going to use, which over time might build up to soil levels that are excessively high, which will lead to leaching, possible reduction in growth or yield, and possibly lead to damage to the environment. with that, that ends the soil testing portion of my presentation, and we can take questions.